Afternoon, students. My name is Rajesh. So we have met. We met in the last semester. That is for DMM one. So because of these exams, because of this regular exams has been given by the JNTU. So we don't have other option. So we don't have other option to start. So we are taking the classes online. So the subject what we had in the second year, second semester is dynamics design of machine members 1. So in this semester I think you are having DMM 2. It will be very little bit easier when compared to DMM 1. So in this week we will complete the DMM 1 syllabus, all the units, not detailedly in brief. So in the classwork also I have given majority of notes as well as discussed the topics of this DMM 1. So in this online session, so till Saturday or Sunday, so we'll complete all the units successfully. So one day, one unit. So one unit takes around minimum 2 or 3 classes, depends upon the content. But when you compare DMM2 in the third year, first semester, teaching by your Naresh sir, so this DMM1 will be very little bit faster, and there is no comparison between DMM2 and DMM1. So మనకి టైం లేదు కాబట్టి సో ద స్లైడ్స్ విల్ బి షార్టర్, టాపిక్స్ కరెక్ట్ టాపిక్స్ నేను ప్రజెంట్ చేస్తాను. బట్ మై presentation will be a little bit faster. Why? Because we don't have time. That's why I have to complete each unit one day by taking 2 or 3 classes. So you also bring your running notes. మీకు ఇచ్చిన notes మెటీరియల్ ఏమన్నా ఉంటే keep the running notes in front of you in this online session. Just see what topics we have covered and what to be covered in this classes, right? Yes. So here we are discussing about the unit 6, right? So we will start from back to front. So we will discuss now unit 6. So in the unit 1, so we have the basic concepts of unit 1, that is general considerations in design, engineering materials, the properties, manufacturing consideration, stresses in machine members. So like this we are having the various topics in the unit 1. So coming to the unit 2, we are having the strength of machine elements. So what is the strength of any machine element has, and also the various types of fatigues, various types of fluctuating stresses, endurance limit, estimation of endurance strength. We are having some sort of derivations. Coming to unit 3, we are discussing about totally the riveted and welded joints. The riveted and welded joints. That is the design of joints with initial stresses, design of quarter joints, design of bolts, stresses, different types of eccentric loading, both uniform and different seals. Coming to the unit 4, we are discussing other mechanical device, that is keys, quarters, and knuckle joints, right? So we discuss the topics like keys, quarters, and knuckle joints, how the design of keys, how the design of quarters, how the design of knuckle joints has been derived. So we will have a briefing session, just a revision. So complete game undadu, detail ga cheppalenu nenu because of no time. So I will brief you all the topics in general, right? Next, unit 5, we are having the topic called shaft couplings. Introduction to the types of couplings. What are the various types of couplings? What are the materials used for couplings, right? So what are the properties of couplings? What are the stresses involved in the couplings? Coming to the couplings, we are having rigid couplings, muff coupling, split coupling, and flange couplings, flexible couplings. All these topics are already discussed in the classwork itself. Next, coming to the unit 6. In the unit 6, we are discussing other mechanical element, that is mechanical springs. Okay, so in this mechanical springs, we are having what are the various types of helical springs, what are the stresses, strains, and deflections involved in the helical strings, right? So in that we are having compression strings, extension springs, and different types of loading capacities, right? So and also we are having other types of springs like coaxial springs and design of leaf springs. So we will discuss these topics in this session. So the textbooks that is to be followed for this unity for this subject is machine design by Pandari, machine design by Pandya and Shah, machine design. So moreover, to pass or to get score in this subject, definitely you have to refer your data book. Data book is mandatory. Data book is mandatory. So without knowing, without getting the knowledge of data book, you can't do anything in the DMM1. So that's why I'm insisting you. I already said you in the classroom also. So for this for this DMM1 subject, definitely you have to bring your D design data book. That is very, very important. So without bringing your design data book, we cannot do anything in this unit. DMM1 as well as in DMM2, right? So like this, we'll start the class. So I will give only one or two problems in this online session. So ఎక్కువ problem discuss చేయను. At the same time, there is no time. Once again, I'm repeating you, by Saturday or Sunday, I will complete the total topics in brief. DMM2 లాగా డీటెయిల్గా చెప్పడానికి ఇక్కడ no time. So just మీకు revision briefing ఇస్తాను. What are the important topics to be covered, right? And also I'll give some of the important questions which comes in your mid 2. Okay. Next, coming to the unit 6. So mechanical springs. So I think you have seen the spring everywhere, right? So for example, in your ball pen also, spring ball pen, button type ball pen also, if you open your so coming to the mechanical springs, so you have seen the spring everywhere in your daily life. In your pen, you can see the spring, right? In your watch, you can see the spring. In your cell phone, you can see the spring. In your cycle, you can see the spring. You can scooter, you can see the spring. Everywhere in the mechanical device, wherever you are having some sort of connection between the two joints or links, whenever there is a spring action, you can see the springs. But coming to the types of springs, you are having variety of springs that are generally available in the market. So springs are the mechanical elements. Springs are the mechanical elements that deflect under some load, absorb some energy, store the energy, and release whenever it is required. And when the load is removed, the spring also come to the same position. The work as shock absorbers. So what they will do, like they work as shock absorbers in automobiles, used in mechanical clamping and machine tools, used in inlet and outlet valves of the IC engine. Tension springs are used in watches and toys, right? The torsion springs are used generally in watches and toys, which are very tiny objects. Springs have been used in the field of machine design, such as to cushion impact and shock loading. So where it is used for all the machine design objects, machine design elements, we are using the springs in order to absorb the shock loading and also the have some cushion impact, and also to store the energy and to maintain contact between the machine members, which are used for measuring devices, spring balances, and control of the vibrations. So these are the main reasons why we are using springs for this mechanical members. Okay. To the types of helical springs. So in this unit, so the main things is to discuss about the helical springs, coaxial springs, and leaf springs. ఈ మూడు స్ప్రింగ్స్ గురించి మనము ఈ యూనిట్ లో డిస్కస్ చేసుకోవాలి. సో ఎవ్రీ యూనిట్ ఐ విల్ టేక్ 2 or 3 సెషన్స్ పర్ డే, 1 day 1 యూనిట్. సో ఒక రోజు మీకు ఒక యూనిట్ తీసుకుంటాను. డిపెండ్స్ అపాన్ ద టైమింగ్, ఐ విల్ ప్రొవైడ్ ద లింక్. ఇఫ్ నాట్ పాసిబుల్, I will record it, I will online, I'll keep the link in your group so that you can watch the videos. Once the unit is completed, I will send a PPT to your group so that you can open the PPT and you can see the topics. Okay. So coming to the helical springs, you are having three types of helical springs. One is compression type, other one is a torsion type, other one is a extension type of spring. So if you see the figures of the compression type, see this spring. So if you go to any two-wheeler automobile shop or any cycle shop, you can see number of springs. So this is a compression spring. The material is different, the processing is different. Next, if you see the torsion spring. So here also the material is different and the application is also different. Though this type of torsion spring where you can see this type of springs in your clamps, in your pad, exam pad kuntundi kada, you can see that type of spring. And also for your hangers, బట్టలు ఆరేసుకోవడానికి మీరు హ్యాంగర్ యూజ్ చేస్తారు clips, there also you can see this type of springs, right? Next, coming to the extension springs. So if you see the extension springs, see here, this is the extension spring. So ఇక్కడ మనం నాట్ చేస్తాం, టై చేస్తాము, ఇక్కడ మనం నాట్ చేస్తాము. So thereby the spring will get elongated, right? So ఇక్కడ ఏం జరుగుతుంది, because of these two knobs here, because of these two opposite knobs, what it will compress it. But here directly we are compressing. From this side we are applying the pressure, from that side we are applying the pressure, just like your shock absorbers, right? Shock absorbers of your two-wheeler. Next, what is the definition of a spring here? Springs are elastic bodies, generally metal or plastic, that can be twisted, pulled or stretched by some force. They can return to the original shape when the force is released. In other words, it is also termed as a resilient member. Coming to the classification of the springs, you are having the helical springs, leaf springs. In the helical springs, ఇందాక మనం చెప్పుకున్నట్టు tension helical spring, compression springs, torsion springs, and spiral springs. The leaf springs are totally separate springs. These are the flat objects. Leaf springs ఎక్కడ చూస్తాం generally? We see the leaf springs for your heavy automobiles, పెద్ద పెద్ద buses, cars, trams, your trucks, you can see the leaf spring. Next, so if you see the figures of the types of springs, you can see this is a compression helical spring, tension helical spring. So the cross section of the compression helical spring, the 2D diagram of this helical spring. This is a conical spring, this is a volute spring, this is a helical torsion spring. So this is a side view, this is a front view, this is a spiral torsion spring, so which we can see this type of springs in your watches, and a disc or bevel springs. Next, coming to the laminated or leaf springs, which are used in your trucks, trams, buses, cars. And next one is a flat spring. This one is a flat spring. So these are the various types of springs you can commercially available in the market, which are used for different machine members, right? Next, if you see the original figures of above said the line diagram figures. So how the helical springs are looking like? See the helical compression spring, this is a helical extension spring, this is a conical spring, this is a torsion spring, where you can see in your daily applications like your clamp, your exam pad, like that, right? Just I will mute it. Okay, so only 3 members are in the class out of 40 members. I cannot do anything. Just giving the information is the first thing for the faculty. So time లేదు కాబట్టి నేను మీకు ఫాస్ట్ గా చెప్తున్నాను. Otherwise there is nothing to do to go fast. So I will మీకు తెలుసు, I will take the classes, number of classes, but because of the no time, so I'm taking very fastly. And coming to the laminated spring, so you can see the leaf spring design like this, which is available in your vehicles. The disc or bevel springs. So these are the real-time springs where you can see in the market. Next, coming to the introduction of the spring, what are the objectives or the features of the springs ante ivi rayali. So when you get a question, so in the part A, definitely you will get one question about the spring. Define leaf spring, or what are the properties of a spring, right? Or classify the helical springs and even topics వచ్చినప్పుడు you have to write this type of concepts. So what is the purpose of to store the energy in the watches toys, to measure the forces, spring balances and engine indicators, to control motion by maintaining contact between two elements and cams and followers. So these are the various types of applications మీరు as it is మీరు బట్టి కొట్టాల్సిన అవసరం లేదు, right? So you can write your own application wherever you have observed or saw. ఎక్కడైతే మీరు చూసారు రియల్ టైంలో దాన్ని గుర్తుపెట్టుకొని you can write your own words. Coming to the, if you want to write anything, coming to the types of springs, helical springs. Helical springs are made up of wire coiled in the form of helix, primarily intended for compressive or tensile loads. So ఇది వచ్చేసి compressive, ఇది వచ్చేసి tension. కంప్రెస్ అన్నప్పుడు ఇలా కంప్రెస్ అవుతుంది. సో ఇక్కడ నుంచి ఒక ప్రెషర్, ఇక్కడ నుంచి ఒక ప్రెషర్ పెట్టుకొని కంప్రెస్ చేస్తాము, లైక్. సో ఇదేంటి టెన్షన్. టెన్షన్ మీన్స్ ఇక్కడ మనం ఒక లింక్ వేసి ఇటు లాగుతాము, ఇక్కడ ఒక లింక్ వేసి పైకి లాగుతాం. ఫర్ ఎగ్జాంపుల్ వెయింగ్ డివైస్ ఉంది అనుకోండి. ఫర్ ఎగ్జాంపుల్ మీరు ఎనీ చికెన్ షాప్కి వెళ్ళారంటే ఇఫ్ యూ వాంట్ వెయి ద హెన్, కోళ్ళని, లేదంటే ఇఫ్ యూ గో టు ఎనీ మిర్చి యార్డ్ ఆర్ సమ్ అదర్ థింగ్, సో ద పర్సన్ ఈస్ హ్యావింగ్ ఎ స్మాల్ డివైస్. సో కోడ్ని తీసుకెళ్ళి దానికి కట్టేస్తే స్ప్రింగ్ వచ్చేసి సాగుతుంది. దేర్ బై యూ కెన్ సీ ద రీడింగ్. దట్ ఈస్ ద టైప్ ఆఫ్ tension helical springs. Coming to the conical and volute springs. The conical and volute springs shown in the figure are used for special applications where the telescopic spring or a spring with a spring rate that can be increased the load as desired. So these are used for the special applications. Next one, third one is torsion. This may be helical or spiral, shown in the figure, used only in applications where the load tends to wind out the spring in various electronic measuring devices. Next one, helical torsion spring, spiral torsion spring. Next one is laminated spring. So the laminated spring is also known as leaf spring, flat spring, carriage spring, consists of number of flat plates known as leaves of varying lengths held together by the means of the clamps and bolts. So ఇది ఒక పెద్ద బోల్ట్ ఉంటుంది, ఇది ఒక క్లాంప్ ఉంటుంది. ఇఫ్ యు సీ ఆన్ ద రోడ్ సైడ్, ఎప్పుడైనా మీరు నడుచుకుని వెళ్తున్నప్పుడు పక్కన లారీ బస్ ఆగి ఉంటే జస్ట్ బో డౌన్ యువర్ హెడ్, ఒకసారి వంగి చూడండి, టైర్లకి రెండు టైర్లకి మధ్యలో యూ కెన్ సీ ద స్ప్రింగ్. సో టోటల్ యూ కెన్ సీ 4 springs like this. Next one is disc or bevel springs. These are the springs consist of a number of conical discs held together against the slipping of the central bolt of a tube. Special purpose springs. So like this you are having various types of springs. If you get any question theory ga rayalannappudu ila rayandi, simple figures vesi write that. Next, the terms used in the compression springs: solid length, free length. Ante kada, solid length and the free length. So what is the solid length here? The free length of the spring LF is equals to solid length plus maximum compression plus clearance between the edges and coils. సో డెరివేషన్స్ కూడా మీకు క్లాస్లో మీరు రాసుకున్నారు చాలా వరకు. సో ఇక్కడ అన్ని నేను ఫాస్ట్గా చెప్తాను, జస్ట్ మీకు ఒక రివిజన్ చేయడానికి మాత్రమే దిస్ ఆన్లైన్ క్లాసెస్, నాట్ రెగ్యులర్ క్లాసెస్. రెగ్యులర్ క్లాసెస్ అయితే మినిమం ఐ విల్ టేక్ 70 to 80 క్లాసెస్, బట్ దేర్ ఇస్ నో టైం. సో మీకు ఫాస్ట్గా చెప్తున్నాను, మీరు కొంచెం కన్ఫ్యూజ్ ఉన్నా కూడా అర్థం చేసుకోవడానికి ట్రై చేయండి. సో దిస్ ఇస్ ద ఫ్రీ లెంత్ వేర్ యు ఆర్ హ్యావింగ్ ద డయామీటర్ ఆఫ్ ద స్ప్రింగ్, రైట్? దిస్ ద పిచ్, ద డయామీటర్. తర్వాత ఏం జరిగింది? కంప్రెస్డ్ జరిగింది. ఇక్కడ ఏం జరిగింది? ఫుల్ కంప్రెషన్ జరిగింది, రైట్? సో బేస్డ్ అపాన్ దట్ compressed length and the compressed solid, so what is the free length here? The free length is equals to solid length plus maximum compression plus allowances. So what is the formula here? This is the formula. Next, spring index. Spring index is equal to C is equals to capital D by small d, where D is equal to mean diameter of the coil, small d is equal to diameter of the wire. Next one, spring rate. So what is the spring rate here? The spring rate is equals to K is equal to W by rho. W by rho. What is the rho here? Where W is equal to load and deflection of the spring, right? Next one, coming to the pitch. What is the pitch here? The pitch is equals to free length by n minus 1. The pitch is equals to free length by n minus 1. It is defined as the axial distance between adjacent coils and the incompressed state. So in this unit, generally, you will get one theory question and one or two problematics in the part B. So part B లో you may get the leaf springs గురించి ప్రాబ్లం రావచ్చు, లేదంటే కోయాక్సిల్ స్ప్రింగ్స్ గురించి ఒక ప్రాబ్లం రావచ్చు, లేదంటే హెలికల్ స్ప్రింగ్స్ గురించి ఒక ప్రాబ్లం రావచ్చు. Apart from that problem, some derivation, small derivation, right? So but for everything, you have to keep your design data book. But I don't know from this year design data books are not allowed అని చెప్తున్నారు. But I don't know exactly because the exams are going on in our college. So definitely design data books ఇచ్చే ఛాన్స్ ఉంటుంది, right? So all of you, first thing ఏంటంటే all of you should get aware of this design data books. Design data books గురించి ముందు అవేర్నెస్ తెచ్చుకోండి, లేదంటే it will be a big problem, right? Next. So generally, if everything you are having the derivations. So if you open the design data book, old book or new book, so generally you are having the derivations of each and every component. Springs and దాని గురించి ఓపెన్ చేస్తారంటే springs unit in the design data book, you can see the spring total concepts also, right? So if you see the stresses in helical springs of a circular wire, so this is a general nomenclature. D is a mean diameter, small d is the diameter of this thing, n is the number of coils, g is the modulus rigidity, w is the axial load of the spring, tau is the maximum shear stress. ఇవన్నీ మీరు గుర్తుపెట్టుకోవాలి. This is equal to tau, w is equal to axial load. So the notations you have to keep in mind. Spring index is equal to mean diameter by diameter of the spring wire. P is equal to pitch of the coil. Rho is equal to deflection of the spring. So based on this one, so you are having the formula, the twisting moment. Even manaki whatever the formulas in this units, everything it will be in the design data book. Only the thing is, మీరు external exam lo, if they provide the book, it will be very easy, or you have to learn some of the formulas, or else definitely you will fail. మీకు already class lo kuda cheppanu, majority of the people will fail in DMM1, also in DMM2, but మీరు ఎవరు కూడా సీరియస్ గా తీసుకోలేదు, రైట్? నెక్స్ట్, కమింగ్ టు ద ట్విస్టింగ్ మూమెంట్. Twisting moment T is equals to W into D by 2, that is equal to 5/16 tau 1 into T cube. Therefore tau 1 is equals to, this is the formula. Tau 1 ఏంటి? Tau means the maximum shear stress. Tau is equals to 8WD by pi D cube. So coming to the resultant shear stress, tau is equals to tau 1 plus or minus tau 2, that is equal to 8WD by pi D cube plus or minus 4W pi D square. Therefore maximum shear stress induced in the wire is torsional shear stress plus direct shear stress. So this is a formula. So after substituting this one, you are getting this one. Substitute D by D is equal to C. Therefore Ks is equal to shear stress factor, that is 1 plus 2C. The maximum shear stress induced in the wire is tau is equals to K into, write this one, K into 8WD pi D cube, that is equal to tau into this one, where K is equals to value this one. Next, the deflection of the helical springs of a circular wire. So the derivation, so when you get any question, derive the deflection of helical springs, you have to write this thing. So this will be available in the design data book also. మనకి ఎగ్జామ్స్ మనకి సెంటర్లో జరిగితే, so I think so definitely they will keep the exams in our center only. So the design data books is allowed, then it will be very easy. But direct గా మీరు ఎగ్జామ్స్ లో డిజైన్ డేటా బుక్ మీకు ఇచ్చినా కూడా it will not do anything. Why? Because మీరు ముందుగానే ఎగ్జామ్స్ జరగక ముందే ఒకసారి బుక్ ఓపెన్ చేసుకొని మీరు చూస్తే కానీ మీకు ఒక ఐడియా ఉండదు, రైట్? So these are the simple things where we are deriving and we are getting the calculations, right? These are the formulas what we are derived. So based upon the formulas, this is a small problem. A helical spring is made up of a wire of 6 mm. right? Diameter of spring is 6 as outside diameter of 75 mm. If the permissible shear stress is 350 MPa and modulus of rigidity 84 kilonewton per mm square, find the axial load when the spring can carry the deflection per active turn. Active turn. What is the given solution? D is equals to 6 mm. D naught outer diameter 75 mm. What is the stress here? 350 mm. What convert MPa into Newton per mm square. Conversions are already తెలుసు ఉండాలి, right? Next one. What is the G here? G is modulus of rigidity. G is 84 kilonewton. Convert into Newton mm square. Kilonewton నుంచి Newton convert చేయండి. Now, what is the diameter? D is equals to D naught minus D. Capital D is equals to D naught minus D. That's equal to 69 mm. So, what is the C index? C index మనము capital D by small d. That's equal to this one, right? Next, W is equal to axial load. Rho by N, deflection per active turn. Then what is the thing you have to find? So, ఇవన్నీ ఎలా తెలుస్తుంది? So, design helical spring అన్నప్పుడు, so you have to learn the some of the notations how to design it, or in the design data book you can see the step by step. So design data book lo formula చూడాలి, ఈ values దానిలో ఎక్కించేసి you will get the answer. So seeing the formula, keeping the values, doing the problems. That is the concept of this DMM1. So you are neglecting the effect of curvature. The formula Ks is equal to 1 plus 2c, that is equal to 1 by 2 into c value ekkiste you will get the values. Maximum shear stress induced in the wire tau, that is equal to 350. 350 is equals to Ks into 8WD by d cube. So after substituting this one, you are getting this one. The W is equals to 350 divided by 0.848, that is equal to this answer. Next, the deflection of the spring is tau minus 8W d cube into N by G into D4. So substituting like this, you are getting the answer. Next, considering the effect of curvature. So first to find the K value by substituting this value, this formula. So after doing this one, substitute the maximum shear stress. So finally you get the W is equal to this one. Therefore, the deflection of the spring is this formula, same formula 8W. So in the raster formula, we can substitute cheyandi. That is 8 into W d cube into N by G into D4. Therefore, deflection per active turn by N. Therefore, the value is 9.26 mm. So I'll provide the PDF soft copy also. At the same time, at the end of the every unit, I will provide the PPT in your group. Coming to the spring materials, the main types of spring materials. What are the materials used for the springs? Are hard drawn high carbon steel, oil tempered high carbon steel, stainless steel, copper or nickel based steel, prosperous bronze, inconel material, monel material, right? Titanium material, chrome vanadium material, chrome silicon material. So these are the various types of materials you are using for the spring manufacturing. Next, stresses induced in the spring. So what are the various types of stresses that are induced in the spring? When subjected to axial load, when subjected to the axial couple, you are having two types of springs. See, when they are subjected to the axial load, what happens? So if this is a spring, closed coil spring, so whenever this is the diameter of the spring, this is the diameter of the rod, this is the outside diameter. So whenever see the section of the spring axis of the coil, so if you are taking the axis of the coil, so the twisting moment M is equals to WD by 2, the torque is equals to M cos alpha, the bending moment MB is equal to M sin alpha, right? So based upon this one, let D is equal to diameter of the coil, D is equal to wire, N is equal to number of coils, L is equal to length of the wire, angle is equal, alpha is equals to angle of the helix. Therefore, moment at any point W is equals to moment at any point M is equals to W into d by 2. The vector component T is equals to m cos alpha, mb is equals to m sin alpha. The vector component along the axis torque will be equal to the m. Therefore, T is equals to m, that is equals to w into d by 2. Okay. The total length of the spring is pi d into n, right? N is equal to number of turns. Next, total volume of the spring is pi d square by 4 into pi dn. Next, using a torsion formula, Tj is equals to Fs by R, where Fs is equal to shear stress, Tj by T by J into R. Then what is R here? T into d by 2, by J. What is J here? Pi d square, pi d 4 by 32. So upon solving this one, T is equals to 16d by pi d cube. So we know that T is equals to W into d by 2. So ఇక్కడ ఉంది కదా d into d by 2. Therefore, Fs is equals to 16 by pi d cube into WD by 2. Therefore, Fs is equals to 8WD pi d cube. So these are the simple derivations based for the problems. Coming to the axial couple, when subject to the axial couple, so it is a twisting. So same figure, the same nomenclature. Then what is the thing you have to do? So here m is equals to mb, the strain energy u is equals to m square ds by 2ei, that is equal to m square into l 2ei. So upon solving this one, the rotation of the spring is u is equals to 4 into w square d cube into n divided by g into d to the power of 4. So generally ఈ formulas అన్ని you will see in your design data book, right? Or else you can learn some concepts in the design data book also. Okay. Next, strain energy అయిపోయింది, stress energy. Stress energy అయిపోయింది. Now the strain energy. Here also subject to axial load. Neglecting the strain energy, W, the strain energy stored, U is equals to F square S into 4G divided by 4G into volume. Now, deflection of the springs. Coming to the deflection of the springs. Let tau is equals to axial deflection anukunte, then the work done by the load is equals to half W into tau. Equating the work done energy, the strain energy stored, that is equals to half W tau is equals to 4 into W square D cube into N by GD to the power of 4. Therefore, tau is equals to, epsilon is equals to 8 into W D cube to the power of N divided by G2 to the power of 4. So upon solving this one, 64 WR cube N by GD4. So these are all the things, formulas you can see in the design data book also. Coming to the stiffness of the springs. The stiffness of the spring is defined as the load required to produce unit deflection. Therefore, the stiffness of the spring is equals to W by epsilon, that is equals to GD to the power of 4 divided by 64 into R cube into N. Okay. Next one is proof loading. Proof loading is a maximum load carried by the spring without getting permanently distorted. So whenever you are doing any application, so it is a maximum load carrying capacity of the spring without getting any permanent distorted, right? Next one. So based upon this 15.2, this formula, based upon this one, deflection. Proof load Fs is equals to 8WD by pi d cube. So the proof load W max is equals to pi d cube by 8d into Fs max. That implies pi d cube by 16R into Fx max, 2 times the proof load, where Fs max is the available shear stress of the material of the spring. So these are the some of the derivations and also the formulas to be done for this helical spring. We'll do some of the problems here. So if you see a closed coil A closed coiled helical spring is made 5 mm diameter of wire. It is made up to 30 coils. N is equal to 30. Each of the mean diameter is 75 mm. Outer diameter is 75 mm. If the maximum shear stress tau, if the maximum shear stress of the spring is not to be exceed 200 MPa, then determine what the proof load and the extension of the spring when carrying the load. Now take the value G is equals to 80 GPa and it should. Now what is the first thing you have to do? For every problems, keep in mind for every problems DMM1, DMM2, other subjects, heat treatment, whatever the problematic subjects you are getting, first write the given data. Make a problem ki solution రాకపోయినా కూడా read the question 2 or 3 times. Try to write the given data. డేటాను బేస్ చేసుకొని ఫార్ములా వేయండి. ఏం కనుక్కోవాలని రాయండి సపరేట్గా. టు ఫైండ్ గివెన్ డేటా రాయండి, తర్వాత టు ఫైండ్ రాయండి, తర్వాత ఫార్ములాస్ రాయండి. క్యాలిక్యులేషన్స్ మీకు మ్యాక్సిమం ట్రై చేయండి, రానప్పుడు వదిలేసేయండి. సో దట్ యూ విల్ గెట్ మినిమం మార్క్స్ టు ద గివెన్ డేటా. ఏం కనుక్కున్న దానికి డేటా, ఫార్ములాకి ఒక 1 మార్క్, ఫిగర్ వేస్తే దానికి ఒక 1 మార్క్స్. టోటల్లీ మీకు ఏమి రాకపోయినా కూడా ఇఫ్ యూ అటెంప్ట్ ఎనీ క్వశ్చన్ by writing the minimum basic things, you will get minimum 3 or 4 marks. నీట్గా రాశారంటే you will get minimum 3 or 4 marks. ఓకే, అట్లా మీరు మెయిన్ ఎగ్జామ్కి మీరు ప్రతి క్వశ్చన్ అంటే చాయిస్ కాకుండా ఇఫ్ యూ రైట్ ద ఆన్సర్ కాన్సెప్ట్ గివెన్ డేటా ఫార్ములా యాజ్ వెల్ యాజ్ యువర్ ఫిగర్, అట్లా మీరు ప్రతిదానికి 3-4 మార్క్స్ మీరు తెచ్చుకున్నారంటే 5 4s are 20, పార్ట్ ఏలో ఒక 10 మార్క్స్ వచ్చినా కూడా టోటల్లీ 30 మార్క్స్. ఈజీలీ యూ విల్ పాస్ ద సబ్జెక్ట్, రైట్? నౌ సీ ద గివెన్ డేటా D is equal to 5 mm, D is equal to 75 mm, N is equal to 30, R is equal to 37.5, R is equal to 37.5, half, because half. G is equal to 80 GVA and the maximum stress is equal to 200 MVA. So from this proof formula, what is the proof formula? This one, W is equals to pi d cube 80d into Fs. Therefore, the proof load is equals to pi into 5 cube divided by 8 into 75 into Fs and the 200. So the value is 131 Newton. Then what is the deflection formula? Deflection formula is it, right? The deflection formula is this one. 8 deflection is equals to 64 into W R cube N into G by GT to the power of 4. Therefore, 64 into 131 into 37.5 into 30 divided by 80 into 10 to the power of 4 into cube into 5 to the power of 4. That is equal to 265.5. So this may be the simple problems you will get for 3 marks or 4 marks in the part B. So in part B, definitely you will get according to your pattern, it may be 8 marks, 7 marks, or it may be 7, or directly 14 marks or 15 marks, depends upon your model paper. Next, coming to the second problem, a helical spring in which the slope of the helix may be assumed small is required to transmit the maximum pull of 1 kilonewton and to extend 10 mm or 200 Newton load. If the mean diameter of the coil is 80 mm, find the suitable diameter for the wire and the number of coils required. Take G is equal to 80 GVA and stress is equal to 100 MPa. So what is the stress formula? The stress formula Fs is equals to 8 into Wd by pi d cube. Therefore, d cube is equals to 8 into Wd by pi into Fs. So this is the values you have to write. Therefore, we know that W is equal to 1000, F is equal to 100 MPa, D is equal to 80 MPa. The diameter of the wire half cheste 12.68, diameter of the spring wire. Deflection is 10 mm and W is equals to 200 mm. The spring constant is equals to K is equals to W by deflection, that is 200 by 10, 20. That is 2 into 10 to the power of 4 Newton per meter. Next, we know the C value is 80 GPa. Deflection formula anti, this is the deflection formula. Therefore, N is equals to En left తీసుకురండి, values అన్ని ఇక్కడ ఎక్కించండి. Therefore, substitute the values. So finally, you will get the answer. Simply we can say 26 number of coils. Number of coils are 26. So that is the thing you have to do. Next problem. A closed coil, a closed helical spring of circular section 75 mm mean diameter, when loaded to the axial load 250 Newton, it is found to extend 160 mm. Subject to the twisting couple is 3 Newton meter. The rotation is 60 degrees. Find the Poisson's ratio for the material. First write the given data. D is equal to 75 mm. Deflection is 160. W is equal to 250. Twist is equal to 3 Newton meter. Angular rotation is 60 degrees, right? Then what is the Poisson's ratio? Then deflection ఉంది కాబట్టి deflection ఫార్ములా వేయండి. సో వెన్ యూ గివెన్ డేటాలో మీకు ఇలాంటి వాల్యూస్ వస్తే, ఇలాంటి వాల్యూస్ వచ్చినప్పుడు డిఫ్లెక్షన్ ఇచ్చాడు కాబట్టి డిఫ్లెక్షన్ ఫార్ములా వేయండి. ట్విస్టింగ్ టీ ఇస్తే ట్విస్టింగ్ మూమెంట్ వేయండి. జీ వాల్యూ ఇస్తే జీ ఫార్ములా వేయండి, రైట్? So now the using this relationship, twisting is equal, the deflection is equals to 8 into W into dq by n by g into d to the power of 4. Therefore, g మీరు మనకు కావాల్సిన g కాబట్టి g ని మీరు బయటికి తీసుకొస్తే there is a formula. Now applying all these values here, applying all these values in the formula, so keep on solving. Finally, you are getting this one. So మనకి d తెలియదు కాబట్టి g ఇంతవరకు మనము ఒక కండిషన్ లో పెట్టుకున్నాం. Next was axial torque formula ఏంటి? The torque formula 64 into T into D into small n divided by capital E into D to the power of 4. Now దాంట్లో మనం E ని పక్కకు తీస్తే, so this is the thing you will get. So substitute 64 into twisting 3 into D into n divided by this one. So E value is, this is B. Now we know the relationship E is equals to 2G into 1 plus V. Substituting values of E and G from A and B. So what you are getting? So A value and this is the A, this is the A. This is a B. This is a B. Therefore, after doing this one, so 1 plus V is equals to this value. So substituting this value, you are getting 1.304. Therefore, V is equals to 1 minus 1.304. That is 0.304 is the answer. Right? Next one is leaf springs. So here the time is up. The time is up. Very less here. So if you have no doubts today, just you can unlock your mic and you can talk to me. Anything to discuss? So next class you are having at 4 o'clock. 4 o'clock I have the other class, civil branch 4 to 4:40. Okay, you are having the class at 5 o'clock, 5 to 5:40. Make your students 5 to 5:40. I will try to complete unit 6. లేకపోతే ఇంకొక క్లాస్ తీసుకుంటాం. But this is only the revision classes, not regular class. So if you see my regular classes, చాలా late, చాలా స్లోగా తీసుకుంటాను. Why? Because if you see your current semester, I am taking for civil engineering branch. So I'm not interested to take this type of classes. The fast గా వెళ్ళడం నాకు ఇష్టం లేదు. But there is no time. మీరు ప్రిపేర్ అవ్వాలి. So prepare your timetable, right? So according to your timetable, plan yourself and prepare your exams. So by Thursday, Friday, Saturday, I will give the important questions which will comes in the DMM 2 or DMM 1. At the same time, design data book మీకు ఎక్కడన్నా కనిపిస్తే తీసుకోండి, లేదంటే ఎవరన్నా ఫ్రెండ్స్ దగ్గర షేర్ చేసుకోండి. Just see the book so that you can come to know what's happening. But I don't know exactly DMM design data book ఇవ్వరని చెప్పారు. మనకి ఇప్పుడున్న కరోనా పాండమిక్ సిచ్యువేషన్లో if they provide in our college, it will be very useful for you. But before that, I will ask the management. If they provide, it will be very easy. అది లేకపోయినా కూడా మీరు ఫస్ట్ ప్రిపేర్ ద కంటెంట్, నో సమ్ డెరివేషన్స్. మీకు ఆల్రెడీ నోట్స్ కూడా ఇచ్చాను. దాన్ని చూసుకుంటే మీరు కొంచెం ప్రిపేర్ అవ్వండి, రైట్? సో విల్ మీట్ ఇన్ ద నెక్స్ట్ 5 o'clock సెషన్, విల్ కంప్లీట్ ద యూనిట్స్. చెప్పు బాబు.
సార్
మహేష్
కొంచెం అదే సిలబస్ అది ఇంపార్టెంట్ కాకుండా డిఎంఎం సంబంధించిన డెరివేషన్స్ మీ దగ్గర ఉన్నాయి, ఇప్పుడు ఎక్స్ప్లెయిన్ చేశారు చూడండి సార్.
అవును, ఎక్స్ప్లెయిన్ చేస్తానంటే మీకు నేను రన్నింగ్ నోట్స్ రాసుకున్నారు కదా.
రన్నింగ్ నోట్స్ అంటే కొంచెం మిస్ అయింది సార్, అది అక్కడక్కడ.
అదే నేను మీకు ఎవ్రీ యూనిట్ అయిపోయిన తర్వాత మీకు యాజ్ ఇట్ ఈస్ పీపీటీ మీకు గ్రూప్లో పెడతాను, వీడియోస్ చూసుకోండి. యూనిట్ అయిపోయిన వెంటనే మీకు పీపీటీ మొత్తం మీ సిలబస్లో ఏమేమి ఉందో పీపీటీలో అదే పెడుతున్నాను. యాజ్ ఇట్ ఈస్ పీపీటీ మీకు మీరు డౌన్లోడ్ చేసుకొని చూసుకోవచ్చు. సాఫ్ట్ కాపీస్ ఉంటే నేను సపరేట్ ఎవ్రీ ఎండ్ ఆఫ్ ద క్లాస్, ఎవ్రీ ఎండ్ ఆఫ్ ద యూనిట్ ఐ విల్ ప్రొవైడ్ ద పీపీటీ ఇన్ యువర్ గ్రూప్. ఆ పీపీటీ ఓపెన్ చేసుకున్నారంటే మీరు మిడ్ 2 వరకు యూ విల్ బి సేఫ్. దాన్ని కూడా మీరు మెయిన్ ఎగ్జామ్ కూడా వాడుకోవచ్చు. దానిలాగా ప్రిపేర్ చేస్తున్నాను. సో గివ్ మీ సమ్ టైమ్.
ఓకే సార్. ఓకే సార్.
రైట్. సో 5 o'clock open the same link. So we'll continue in the 5 o'clock session. So thanks for watching the class. Yeah, have a nice day. So we'll meet in the 5 o'clock session.